Our focus on this lesson is parallel lines. So understanding what parallel lines are, determining if lines are parallel, and then writing the equation of lines that are parallel. So first we should understand that when lines are parallel, it means that they will never intersect with each other. So as you can see, here are two parallel lines, and those lines will never cross each other. What we know about parallel lines is that they will rise and run at the same rate, which is of course why they will never touch each other. So that is going to be helpful later on when we have to write the equation, is we know that those lines need to have the same slope. The first thing we're going to do is determine if these two lines are parallel. So to determine if lines are parallel, we need to find the slope of the line. So you could find a couple of points on this line and then find the slope, and find a couple of points on this line and find the slope. I find it easiest to take each equation and turn it into slope-intercept form. So if I try to get that y by itself, and it's good practice for us anyway, I would first move the 6x to the opposite side of the equal sign, and then I would divide everything by 2. This equation is now y equals negative 3x plus 9/2. If you feel the need to turn 9/2 into 4.5, you may, but you don't need to. And in fact, the only thing I really care about here is that my slope is negative 3. When I repeat this process for my second equation, if I also get a slope of negative 3, but it's not 9/2 or 4.5 as the y-intercept, then I know that they're parallel. So let's add 3x to each side to get y by itself. So this first step gives me negative y equals 3x plus 3. And then I would have to divide everything by negative 1 to get y equals negative 3x minus 3. So as you can see, I've got the same slope, but I have a different y-intercept, and so yes, these lines are parallel to each other. Let's try this one. My first one is 2x plus y equals 4. I would subtract the 2x to get y by itself, which gives me a slope of negative 2 and a y-intercept of 4. On my second example, if I add 2x to each side, that gives me negative y equals 2x plus 3. And again, I'm going to divide by negative 1, which gives me y equals negative 2x minus 3. Same slope, different y-intercept, so yes, these lines are parallel. Of course, I could also graph these lines and see if they're parallel, but this is the mathematical way to do it. What I'm more interested in is to be able to write the equation of a line that is parallel. And so what they're saying is, I want an equation that is parallel to this line. So I don't need to graph this line. If I did graph it, I would probably use my cover-up trick to find that x is negative 2 and that y is negative 8. Oh, 1, 2, 3, 4, 5, 6, 7, 8. So I want it to be parallel to that, but I want it to go through the point 2, negative 3. So I want it to look kind of like this. But graphing it is not what they've asked me to do. They want me to actually write the equation of the line that I've just drawn in. So what I would do is take this first equation and find out what the slope is. I could find out by using that graph and sort of counting, but the easier way is to turn this into slope-intercept form, because we know when we do that, I now know that the slope of this equation is negative 4. And that's what I want, is the slope. So what I'm going to do is I'm going to take this slope of negative 4, I'm going to use my point here for my x1, y1, and now it's just the same process I've been doing for a while. Y minus my y value equals my slope times x minus my x value. I'm going to keep flip change over here. I'm going to distribute that negative 4 and subtract 3 to get y equals negative 4x plus 5. This is the equation of the line. This is a sort of representation of the line, but really we're just looking for the equation. Here's another for us to try. Again, I'm not going to graph this one. I'm just going to go straight to turning this into slope-intercept form so that when I'm done, I know what the slope of my existing line is. When I divide by 6 everywhere, I get y equals 1/2 x minus 2. Again, I don't care about the minus 2. I care about the fact that the slope of this equation is 1/2. And it goes through the point 8, 0. Using point slope form, y minus 0 equals my slope that I'm just stealing from my other equation, x minus 8. And I get y equals 1/2 x minus 4. Try this one on your own, then press play to see how you did. Again, my equation that we are given, we're trying to find the one parallel to that. When I rearrange that equation, I find that my slope of the existing line is -4. So I'm going to steal that slope of -4 and use y minus -1, so that's y plus 1, equals my slope, and then x minus -4, which actually makes it plus 4. I'm going to distribute on the right side of the equation to give me -4x and minus 16 or plus -16. I'm going to subtract 1 to get y equals -4x minus 17.